Okay, thank you, everybody. Goodness me, how do you follow Betty? Actually, you probably have no recollection, but the very first operator community where I gave a technical presentation was NANOG, and I prepared some slides, and unfortunately, Betty had a look at them the day before and helped me make them better. So probably no memory of that at all, but it's. I was looking back and in my archive and see that yes, it was the first conference I ever spoke at. So thank you for your help, helping me find my voice those years ago. This is a presentation that I put together because I've worked on a few automated networks, and there's a lot of content out there and lots of learning, lots of understanding about how to run an automated network from the point of view of writing software, scripts, systems that go and change your network device, go and change what's configured out there. But one of the things that I've learned that's very important is you actually need to be able to not just run an automated network, but run an automated business. Have your network influenced by what the business understands. And I haven't found an enormous amount of content out there about having the automated network take inspiration and instructions from an automated business. So because I've worked on a couple of businesses that have worked like this, I thought I'd put together some slides about the things that I've learned, and you can grab me afterwards and tell me what I've done wrong or not. But let's have a look at what I think. For network engineers, which most people in the room have probably discovered when they first started being able to talk to their equipment using scripts rather than using CLI instructions, a great place to start with automation is producing some scripts that give you reports. What's happening on my network right now? You know, get information out of the network that's actionable and useful. The next part of the journey is you can take that learning. When you write software that gets reports out of your systems, you become more confident, you get more familiar with the tools, the libraries that you can use, and you start to write scripts that impact a change on the network, like something that will automatically bring up peering sessions, for example, in a consistent manner. Eventually, some of those systems start to work together. You end up with a more complete suite of tools that go and set stuff up, and it feels a bit more like an application. You're starting to manage the network rather than manage a device. And you start to have something that actually helps you make decisions about something that's a lot more than just pure configuration. Eventually, the ultimate place to reach, the next step to take, which is perhaps the hardest, is to reach a fully automated and integrated business, a technology business, with a set of processes that are actually enforced and delivered by your automated software. Here you stop configuring the network, but start to configure the entire product. Generally, this is solved by businesses with pretty large scale challenges, such as large access providers, hosting companies. But now this is something that a medium-sized ISP and IXP, for example, can implement. So this presentation is based on that. These are my technical perspectives and thoughts on the architecture of a greenfield deployment of an automated business. We as a business are an internet exchange point as a service operator. We build IXs. So what motivated us to build our network and our product in a fully automated manner? It's because we had to replicate this. Our intention in our business is to build lots of these that are all identical, and you can't do that without process and software. And actually, by getting it right and having such strict but efficient processes at the beginning helps you deliver efficiency and leanness in your business right from the beginning. It helps your customers because they get an assured service. They get a service that works the same way, however it's set up, when it's set up, because it's being delivered by the same tools, the same applications. It allows you to integrate with third-party databases like the IXF database if you're interested in peering, or PeeringDB. Actually, some of the reason we do this is because we were quite frustrated with some of the legacy models that have been used, and therefore the chance to align the business and the technical process with an efficient software stack was in our DNA from the beginning. And the way this presentation maybe differs from other automation presentations you've seen before is it mainly focuses on how and why you should build a data model. And we'll talk about exactly what that is in a moment. And we also hopefully will have time for you to talk a little bit about the way that we architected some of the software and some of the things we do with software testing from a network point of view too. Okay, so what do I mean by data model? I've said it a few times now. What do I really mean by that? And a data model is a structured description of all the things that your business needs to know in order to operate. So it needs to understand which people you interact with, which organizations in your supplier or customer base, and which products that you sell, for example, and the technical elements, configuration descriptions, and infrastructure elements, where your switches are, where your routers are. And the thing to do when you start to build your data model is start by mapping the steady state of the business. When nothing is changing, who are the people, the organizations, what products do we sell? When nothing is changing, what is it that my business knows? And once you've modeled that on probably a very large sheet of paper or a whiteboard, you can then model the interactions between these things. So, for example, a person who works for an organization requests a product which is configured in a certain way. That can be described in a quote. There's a quotation for a product that's prepared for a person and at a customer, for example. And these interactions also need to be modeled. Why would you care about that from an engineering point of view? Why am I standing in front of an engineering conference and saying you need to model quotes in your organization? Actually, there's a benefit to you as an engineer for doing that, because very quickly you realize that, for example, when you're setting up monitoring, when you're monitoring customer services, if you understand, if you've modeled the quotations, if you've modeled the thing that somebody intends to buy from your company, you can monitor the thing that somebody wants to buy, not necessarily the thing that got rolled out. So if you start to model everything to do with an order, you can actually take advantage of that at later stages of the engineering process. Once you've modeled the information, once you've modeled people, processes, products, you have to understand where does this information live in your organization. And actually, whether you're an established organization or whether you're working on a greenfield product, greenfield application, you'll probably find that data naturally lives within different teams in your organization. So invoicing will likely live with finance, and information about prospective customers or current customers might live with sales. Technical information will live in a support function or an engineering function. So you've modeled exactly what information you need, then you model where it is. And it's actually fine for data to live in different tools and different databases around your organization. It's much worse if the data doesn't exist in a database than it does if it exists in databases that are spread out in your organization. But what you have to watch out for is where the same information can live in different databases within your organization, but be subtly different each time. For example, you might find that information about an organization lives separately in your finance system, your sales team, your support teams, where you're thinking about the same organization each time, but subtle differences. And in engineering, maybe we don't care about the organization because, well, we just deal with Fred. And that's not okay. It's not fine for data to be authoritative in more than one place. The data needs to be authoritative in a single place. And other databases around the organization simply need to link and index to that authoritative record. So, for example, if the CRM is going to be the database where information about organizations live, that's fine. But the other tools in the organization need to look at that database in order to get information about that particular type of record. So when you build your data model, you've worked out where you live, where the data lives. It's important to follow some rules of engagement, which is that you store any item of information just once in the organization. There's a benefit from doing that. It means that if you store the information once and that information is wrong in the place that you store it, you only need to fix it in one place and then it's correct across your entire organization. Storing the data once and linking to it for database nerds is called third normal form, and if you want to read more about good design of that, that's something you can look at. When you store that record in a database, it needs to have a unique identifier, which is nothing to do with the data itself. So, for example, an AS number isn't a good record identification number for an organization or whatever, because an organization can have more than one AS, or it might change the AS that it uses or something else. An AS is an attribute, it's not an ID number for the record within your database. And you need to decide where it's authoritative. And because you're working across teams, it's therefore important to have buy-in across the organization when you're planning this. You have to do it as a business. When you're actually modeling your data, now looking at some of the network-specific stuff, when you're modeling your data, you need to be very careful to make sure that infrastructure-centric and customer-centric or service-centric data doesn't live within the same database record. This makes your database much more scalable and easier to maintain from a portability point of view. And a specific example here might be to make sure that information about network ports and network services that live on that port are separate pieces of information. This means that you could stack multiple services on ports further down the line, or it's much more portable. You can move services around to a different port without losing the service history if you separated the infrastructure element from the service element, and that, for example. Once you've modeled your data, you're going to realize that in engineering, you're going to be responsible for a bunch of information. There are some interesting database fashions that you might read about when you're trying to select a database to hold that information. There are many, but there are two common types of database that you might consider. The document store, or NoSQL type of database, and the relational database. Now, I've actually worked on automated networks that have had both kinds of database for authoritative engineering data, and I've found that relational databases suit that better for the needs of an engineering database about services, ports, configurations, this kind of thing. We tried a non-relational database for this on the document store at a previous organization, and the developers really liked using it because it was very extensible. You can define, you can just extend the document when you want to think of storing new types of data as your service evolves. But I actually personally find that strictness is a benefit in terms of building a database that describes configurations, products, ports, and you get a benefit from having a strictly defined database for engineering information. The common sorts of common databases that I actually use in our current stack, we use MySQL for truths about users, ports, and services, and service states, for example, things that are inherently relational in our stack of information that we need to remember. And we use time series databases like InfluxDB to store time series data about that. So port utilization, light levels, error counts, information that is about a single element that changes over time. We use InfluxDB to store information about that. And we also use some third-party databases that I recommend you have a look at as well, like the EuroIX and the PeeringDB database is really good for getting information about what people are going to do with their connections to your network, for example. So now we've talked about the model, we've talked about the fact that you've mapped everything that you need to know, you've mapped the interactions between those things, you've worked out where they're going to live in your organization. It's time to break out a text editor and write some software. Well, what might the architecture look like? The architecture that we've settled on is very similar, is in fact the one on the screen right now. And the area where I like to, the area where I find most interesting is that single API layer in the middle. The API in this architecture acts as a gateway for these many different kinds of database. So we don't use Sugar, but it's an example of a database with an API that can store information about organizations and people. MySQL is where we store information about network elements. InfluxDB, the time series database, and also the gateway to the actual infrastructure where our service lives on switches and servers. They can all be addressed through endpoints on our single common API. This makes it really easy for us to develop and monitor the platform, and much easier to make changes to backend services by just writing technology classes at the back that talk to different databases in the backend through a single API layer. It also makes it easier to expose tools and data to customers. This is a really, really good thing. We learn quite a lot about what's happening on the network. If I learn that I'm incrementing an error count on a particular port, why not actually make that information available to customers via the API if they're going to build tools against our system as well, so that they can see what we see? I'm only running services for their benefit, so why wouldn't I share what I know about the services they're enjoying from us? And having a single API layer that can address all of the information that we know at all as an organization, it makes it easier to expose parts of that to our customers. Also, having a single common API layer gives you a benefit that means you can, no matter what the back-end storage format or the back-end messaging format actually is, whether it's an XML API to a invoicing system, whether it's whether you're going to have SQL databases and the time series database, however the back-end data is stored, you can address it in its native format from your API and expose it to your tools, to your portals, to your customers in a single format like JSON. So you might have to address things via XML, for example, but you don't have to expose that horror to your customers. You can give them nice, clean JSON, consistent data for every kind of information record that you hold. Here's an example, in fact, of what it looks like. We have a single API layer, as I mentioned, and on the JSON document on the left, that is a description of a service. That's called if you have a service with us, you can ask our endpoint, you can authenticate and then ask, what do you know about this endpoint? And I'm collecting information via a BGP collector running Bird, a BGP route server running Bird, that are different servers, our internal SQL database, and exposing that in a single JSON format to our customer, despite the fact that none of these backends actually natively talk JSON. On the right, now this is information about a port which is in use by a customer, and you can, I'm pulling information from the switch, pulling information from our internal SQL database again, pulling information from our InfluxDB database, again exposing it all in a single format JSON to our customer. So our customer can ask for information at one endpoint about their services, and the back-end information can live in many, many places, but a single request to a single endpoint gets that information for the customer in a single format. And that's what that architecture allows you to do. So now we have, now we've got our data model. We've got an API. We've got a way of addressing that model in a consistent manner. How do we actually use that from the point of view of a network engineer? Well, once you have confidence in your data model, once you find that you're using this information, you're using your tools, you're looking at the information, you're changing the information, and it's working, you're confident, you can start to harness that power of network configuration via templates. When your data model extends across the business, you can do that with much greater accuracy and devolved control. What do I mean by that? As an example, we don't actually have anybody in the organization with a provisioning brief in their job. At Asteroid, our salespeople or the customer themselves can deliver exchange ports directly from the quotation. So a customer can describe what they need, a quotation is produced. If everyone's happy, you can actually deliver the port from the quote. When the quote's accepted, it gets rolled out. And the advantage of doing that is we can deliver not just the exchange port and the related services like route server sessions, but we can also deliver our monitoring, so we can monitor what is sold, not what gets rolled out. If you've ever had a situation where you're monitoring what got rolled out, but the customer actually intended to buy something different, if you use the information that's in the quote to roll out the product and to set up your monitoring, then you're delivering what was ordered and you're monitoring what was ordered, not something different. So that these things work together in a bit of a fire triangle. You've got structured data, your data model, data that is correct and complete. You've got templates that describe how monitoring or network ports or server configuration standards should be configured, and you've got a way of rolling that out the automation, which we'll look at in a moment. The templating engine that we use is one called Jinja. I think these slides will be online afterwards, so if you want to have a look in a little bit more detail, you can have a look, or I can share more examples with you afterwards too. The thing I like about Jinja is that it's not actually specific to a particular backend configuration. It's just a way of managing flat files. So if you can generate some plain text as a piece of config, you can develop that quite quickly. You can express that quite easily in a Jinja template. So it can take variables from your JSON API. So in our case, if I put this is a, what does this do? This is a bird configuration snippet that sets up a BGP session. And there's the stuff that stays the same each time, the stuff that gets wrapped around the session, and then there's information that's coming out of our API. You can see in the double curly brackets, like the network's AS number and the IP address. It's all coming from our JSON API. And using the Jinja templates, it allows you to use programmatic methods within your templates. So you can see the top and the bottom line of this config snippet is indicating the start and the end of a for loop. So we loop over that as many times as there's information coming in the JSON. And for rolling that out, we don't actually have scripts for rolling out configuration. I use Ansible for changing server configuration. So this is an example of a task that rolls out that config that's on the last slide actually. So this is instead of having to write scripts that do that, which are pretty similar each time, we just have to manage config files that describe the end state of what it is that we'd like to be configured. So here's a bit of config that goes and gets the information from our API. It goes and generates the config and then rolls it out onto the server and restarts the daemon. You can do conditional logic nicely in the Ansible templates as well. So you're not limited. You can see that line starting when indicates that we should only build a root server session if that is flagged in the JSON as being true. We would like a root server session to be configured. What are the advantages of doing configuration through something like Ansible rather than having a piece of software that you have to write and maintain yourself? Well, you don't need to write and maintain a piece of software yourself. It's already there. It's already complete. It allows the API layer to stay pretty lightweight. All the API layer has to do is retrieve and update database records or retrieve and update information, from a back-end worker. And that's not difficult to write, and you can write it in any language that's familiar to you. There's lots of stuff in there. There's so much good back-end code in Python that a lot of network engineers become very, very familiar with Python very quickly, and I chose to use Python for our API because you get very familiar with it when you're working in network automation. And it also means the automation layer is very, very lightweight. It's just configuration files, the sort of things we've all been using for a long, long time. When you're building a data model and when you're building your API layer, it's important to make sure that the decisions you make when you're building your API and mapping your data allow you to store, retrieve, and process business logic as well as purely technical information. So you remember to model and build tools for everything, not just the things that touch your network. For example, we have a system called the campaigns that allows networks to suggest where they'd like us to build an IX next, or allows someone to support an existing campaign. We model that in the database as well, because it means that when we convert from a campaign to a running exchange, there's a bunch of information that's already in there and already structured that we can use in the initial config as well. So there's a strong advantage to modeling and mapping everything that your organization does, not just the stuff that touches your network. Now, although I said I would talk a lot more about the data model and the stuff for the rest of the business, no network automation talk can be complete without talking a little bit about what we do to talk to the switches and the servers that run our service altogether. And when you're running an automated network, at some point you are going to need to write some stuff that goes and rolls out config. What do you need to consider when you're considering the messaging or the communications between your common API layer and the back end? You need to consider inter-process communication. How are you going to trigger that there's something the API layer needs to instruct the back end? You need to consider how you can map a model the state of a network job. Did that roll out completely? Did it fail? Why? Did it work successfully? State. You should consider stuff to be device independent so that when your vendor evolves to a new configuration dialect or a new product line, or you maybe want to pick a new vendor in the future, you can do so just by writing a new back-end worker rather than a whole new load of stuff. You need to consider as well if you can, in your back-end systems, cope with device swap-outs if there's a device failure, for example. For inter-process communication, there's a couple of ways of considering it, and these are the two that I've looked at before. Actually, both work fine. It could be message queue based, like a system like RabbitMQ. This is a system that allows you to leave a message in a queue, as it says, that describes something that must be done. Something will put a message on the queue saying, "Here's something I would like to be done," and another process picks up the message from the queue and says, "Okay, I'll go and do that for you then." RabbitMQ is a good one because it's got very good support in major scripting languages. It's pretty fault tolerant. You can also impose strict order mattering, guaranteed delivery, high availability. But we didn't use RabbitMQ for this project. We used we built a separate web service layer. So we have a central API, but when we talk to the back-end servers and switches, we go through another web services API. And it's because it allowed us to use an exactly identical technology stack to our central API. When we got familiar with the technology, we just had two platforms that look very, very similar. It's very, very extensible because if it needs to support a feature that isn't in a message queue, it can do it. We just have to write the feature. And it allows this to be decentralized so that as long as the mothership is available, if there can be many, many sites with many, many exchanges, in front of them worker processes that are independent of each other. So if we lose power in one city or whatever, it doesn't affect any part of the provisioning or system in another city. We chose, when it comes to actually rolling out config onto the network devices themselves, I looked at trying to write a generic worker system and a separate worker system per backend. And in the end, we chose this time to write a different worker per backend. Now, this means that there's a bit of copy-paste overhead, which actually is definitely an anti-pattern. If you find yourself copying and pasting code lots of times, it normally means you've done something wrong. But in this case, I decided that it was actually just a little bit of overhead that can be explained, because it means that if I need to treat different vendor systems slightly differently, I don't have to treat them generically. If a particular vendor has a particular quirk, I could address that in that back-end worker system without having to have that hack in all of our back-end worker systems. And I used a system called Napalm because it allowed us to continue with Ansible when we're addressing network stacks rather than addressing, or as well as addressing servers. It allowed us quite a lot of technology consistency. And it means that we can do switch or server switch outs really, really easily, because we just run a Napalm command that says roll out the whole config, and that's our device emergency strategy done. It comes for free with Napalm. Oh, as I said here, there's no need for a specific software feature. Just an operational process saying this is how to do it is okay. Now, something that I don't come from a developer background. I come from a network engineering background, and one of the things that's actually helped me write code that's so far been quite reliable is I learned how to do automated software testing at a previous organization that did automated networking. It was completely new to me at the time, but I would probably credit automated software testing as the thing that took me from a mediocre scripter to someone who's confident enough to actually write more complicated architectures. The important software testing architecture mantra to learn is red, green, refactor. Red, write the test first before you write the code. Run the test. The test won't work because the code doesn't exist. Then write the code, run the test. The test goes green because the code exists and you wrote it properly. Then refactor the code to make it more efficient. Run the test, has it gone red, has it gone green? You start with a working state. You can make improvements to your code for efficiency, for readability, or to make it work better as a library that you just call, for example. And because you've started with the simplest format for that code and prove that the test works, you can then write more complicated stuff and check that it still works by running the same test. Red, green, refactor. And I use, because we use Python, I use PyTest as a framework for testing our backend. There are lots of methodologies on automated software testing. And as I mentioned, because I'm not from a pure software development background, I found the unit testing methodology where you mock outcomes and you mock data and then run tests against that mock data quite difficult to understand and didn't. I found that pretty hard, but I found that writing integration tests that in my development environment went and did the thing for real and then indicated whether it worked or not, to actually be quite easy, and it has my back. So if you're like me, you might find that the methodology of integration testing rather than unit testing is easier to adopt. Write lots of tests. Write tests for everything. Write tests for everything you write, and remember to cover desired exceptions. Where something is important, here's an example on the screen now. I'm writing a test to make sure that a regular user through our API can look at their own contact record, and then check that it can't see other records. So check that the thing that you want to work works, but also check that the thing that you want to catch, the exception that you want to catch, can be triggered as well. And I run the test. Run these tests from scratch every time I write a block of code. You know, it's really, really lightweight. Every time I write anything, run the test, write some more, run the test. You can actually develop frameworks so that you can run the test and carry on writing whilst you're writing the next bit of code, and have something like a growl notification pop up and say, hey, you've broken something, go back. It really does catch stuff. The longer, I think there's an efficiency from writing tests that you get because you spend a lot less time debugging, even though you're spending time writing the test. It's an investment. This is what an error looks like. What did this? Okay, this would have been quite a good one, because what it looks like is I've made a mistake that's broken generating quotes, this is what an error looks like. It goes back. It tells you what you've done wrong. The great thing about this, when you're writing automated tests, is when you're writing stuff, it tells you what you've done wrong, it's much easier to go back and fix a bug when your own computer's telling you you've made a mistake here in this library, in this module, than it is trying to figure out something because a week after you've rolled out a change, someone from accounts can no longer send an invoice. So a couple of extra thoughts. There are lots and lots of ways of expressing information to customers, lots and lots and lots of them. I really can't stress enough the value of expressing information that you know to customers in the JSON format, because so many third-party databases like PeeringDB are making their information available with JSON. You'll find that lots of people in the room that are writing their own applications, scripts and reporting systems that are based on looking in those databases. If you as their vendor can also express data in the same format, all of your stuff can be plugged into work that other people are already doing. So I can't stress enough the value of, if you have to pick a way of expressing information to customers, JSON's the way of doing it. So what is the single source of truth? It's the data model that you make available via a series of tools that's under the control of all departments, not just the engineering department, but all departments can control the information so that they all have a vested information in keeping it accurate, which is used to configure services and the network elements, that's accessible to all departments and accessible to customers as well, so that they can perform more self-service tasks. Information in one place and one tool has generated us so many efficiencies that a significant benefit to our organisation, not least ones such as, for example, our account managers are able to do some of their first line support, for example, using the tools that we give them, which helps account managers do the thing that they really want to do, which is help their customers. We've generated so many efficiencies that I can't stress enough how I'm happy with how we've got to with the automation work that we're doing. Okay, I don't know if there's any time for any questions, but if anybody has any questions, you can either grab me in the hallway in the breaks or ask some at the microphones now if there's time. Steve, is there time? Yep, there is. So if anybody has any questions, I'd be really, really happy to take some. Hi.
Hi, John. Excuse me, John O'Brien, University of Pennsylvania. Could you speak briefly about the technology alternatives, the significant alternatives you considered, and why you went with the stack you described?
Okay, so there's a lot of so there are vendor-specific controllers that you can use that allow you to control network, control network configuration, roll out network changes that give you a head start. You've got to do a lot less writing of software if you're using your vendors like Contrail for Juniper or something like that that takes you further along in the network automation element. But I wanted to be really, really vendor agnostic. I didn't want to actually be tied to any particular part of the system. And when you write your own API layer and worker stack yourself, you have 100% control in vendor selection in the future. As long as the vendor has a programmatic interface, an API, anything that's not Telnet and a expect script, anything better than that, then you've got you're not tied to any particular vendor. I happen to really like our vendor, but one day they might upset me. I hope they don't. And if they do, I'm not tied to their provisioning system, so it can move. In terms of things like ODL and the software controller utilities for orchestration that offers, again, I found it just as easy to use Napalm, and it was less for me to learn. I'd already learned Ansible, which I needed to use to control our servers anyway, but figuring out Napalm was almost no extra work, so it was a shorter step up than learning a different open source controller, for example. And also, I didn't really find something out there that allowed me to reverse back into the business. You know, wanting to understand if I literally want to be able to express a product and make that roll out from our quoting system, how would I plug that into something which is purely focused on network configuration state or and configuration management, for example? I'm going to have to do a load of work anyway, so I might as well just do this, because then I know the data model is exactly as we need it. I don't know if that answers your question or if there's a...
That's fine. Thank you very much. Right. Very nice talk.
Thank you. Hi there.
Hello. Andrew Danf with Linode. I just wanted to talk about, you said you wanted to do a single source of truth across all departments. Was that an effort on your part to coordinate across departments to get that going? In other words, how did you get buy-in from multiple departments to have a single source of truth?
So I don't make any guesses that it's easy in all companies, but I was very, very, very lucky to be able to do this on a completely greenfield idea on this occasion. And one of the reasons that we wanted to start this business and offer this product is because we actually wanted to understand the most efficient way of delivering IXs as a service possible. And there's no way of doing that without modeling and making this repeatable, replicatable, and modeling everything that we know. It's the only logical way of approaching the product that we wanted to build. So I was very, very, very lucky that actually at the time that we decided to build this business, everybody wanted to contribute on a lean, efficient system that works a little bit as the way I described it. We had to evolve the idea a little bit because everybody had good ideas, but there was so much buy-in based on the fact that we were frustrated with the legacy model that everybody wanted to do this work. it's so important to get buy-in from the whole organization. You have no option but to do that. And in a larger organization with entrenched processes, that will be more difficult. But actually, if you do have processes that you can model in your data model, you're actually already part of the way there. If you're a process-driven organization in sales and finance and stuff anyway, that's actually half of the work done, figuring out what it is that you need to do. So it might be possible, hopefully it's possible to get buy-in across departments if you're already quite process-driven.
Thank you.
Thank you. I don't see any more questions, so I think that's it. Thank you so much, everybody.